Let us learn about Boyle's law. Boyle's law. Remember guys, the Boyle's law deals with constant temperature process. Okay, the temperature must be constant. And it deals with the change in volume. Volume change when pressure is changed. Remember that concept. And Mr. Boyle found out that the change in volume of a given mass of a perfect gas is inversely proportional to that of pressure. And remember, pressure has to be absolute pressure. And what is absolute pressure? It is, just remember, it is the addition of atmospheric pressure and gauge pressure. This is just a supplementary note, but the main thing is here. So the Boyle's law tells us that volume of a given mass of gas, and what kind of gas? That should be perfect gas, is inversely proportional to absolute pressure, keeping temperature as constant. If I explain further, just imagine there is a mass of gas. Okay, it is enclosed in a piston vessel. Okay, this one is piston, and the gas, there is gas of m mass. If you apply pressure from here and try to compress this vessel, its volume will decrease for sure. That's just a logical thing, but Mr. Boyle has converted these logical things into its statement, which we are saying as Boyle's law. So at the beginning, the pressure is P1, we are applying the pressure of P1, and initially the volume is V1. Okay, in second stage, as the pressure increases, its volume gets decreased. So if we consider this situation, V1 is greater than V2 and P2 is greater than P1. What does it show? It shows that at initial the volume is V1 while we are applying the pressure of P1. When the pressure is increased to P2, its volume is decreased, which means when the pressure is increased, volume is decreasing. That's what does the Boyle's law explain. It explains that volume is inversely proportional to that of pressure, but pressure, it has to be an absolute pressure. And if we remove this proportional sign, it is going to be equal to C by P. P by P times V equals to C, that is constant. The product of pressure and volume is constant. So if we consider this first case, P1 times P2 is constant, as well as P2 times V2. So we can ultimately say P1 V P1 V1 equals to P2 V2. That's our Boyle's law. And this Boyle's law is graphically represented as shown here. Let us consider one graph. X-axis, y-axis, remember that. And in x-axis we are going to keep volume, because volume is changing when absolute pressure is changed. Okay, so at initial, let us consider the volume is more. Yes, V1, volume is more, V1, yeah, when the pressure is less, P1. As the pressure increase to P2, what happened to volume? Volume will decrease to V2, and this curve shows the change in volume when the pressure is changed. That's exactly what does the Boyle's law explain. So that's what the Boyle's law explains. So for Boyle's law, you have to remember P1 V1 is equal to P2 by V2. So if in numericals, if your P1 is given, V1 is given, P2 is given, and you have to find out P2, you can easily find with this equation. Just make the compression, find the initial pressure and initial volume, multiply that one will be equals to final pressure and final volume. So for this one, since P2 is missing, or we have to find that one, you can do just like this: P1 by V1 divided by V2. In this way, by simple mathematics, by using Boyle's law, you can find what will be the final pressure, what was the initial pressure, what will be the final volume, or what was the initial volume. So that's the use of Boyle's law. It's applicable in further thermodynamic process also, which we will see later on. Thank you for watching. Please subscribe for more videos, and don't forget to like these videos below. Thank you.